Alrighty guys, what is up? Welcome back to Minecraft with Lone Debater 7, and today we're going to be taking a look at an 8-input OR gate. So these are way easy to build, primarily because basically if any of these inputs is on, the output's going to be on. So it's a lot easier to manage than the AND gate, because if lines cross, it may or may not be the end of the world for you. I do need to fix this because I broke that block and didn't place it back down. But okay, so that is the gate built. This is kind of what I did. Obviously this is the output. I just brought it all the way back. That's why there's this trench. You don't have to do that. You can just have it go straight out, and you can have multiple outputs off of all of these. So a redstone torch is going to power any blocks adjacent. So obviously you've got this one which is controlling the output, so you can't place anything in one cardinal direction, but you can place in the three others. So you can have potentially three outputs off of any of these. And the same goes with the AND gate, the XNOR, all this stuff. Like, you can pull, as many different redstone chains off of the gate as you want. So like, if we wanted to have, for example, 6 outputs being controlled by this OR gate, or 6 different things controlled by the OR gate, so when it's powered on, all 6 of these things are going to happen. You can easily do that. You just extend out one and then again, and it scales pretty rapidly. So you can increase how much stuff is being controlled by the output just by adding more redstone, simply like that. As far as the inputs go, you throw down whatever you're going to use. So I like to use levers just because it's a little bit easier to visualize. You can use buttons, of course. That'll just do a pulse, so it's a little bit different. It'll only light up for the duration of the pulse, whereas if we use a lever, it'll always be on, as long as the lever is. So let's kind of dive on in. Basically, the way this works, if any of these levers are flipped, the output will turn on. So we'll just go through all of them and kind of show that off. So we're 4 inputs down and it's still working. Number 5, number 6, number 7, and finally number 8. So it also works, like if any combination of these is turned on, it's still going to output this. So basically, as far as the truth table goes for this, if we're talking digital circuitry or binary, any one is going to equal 1 on the output. That's basically how the logic would be written out for this. So 1 equals 1, meaning that if any of our 8 inputs are in the 1 state, which for us, 0 is when the lever's turned off, 1 is when the lever's turned on. So any of the levers turned, you're going to have an output going. And any combination thereof. So if all of them are on, it's still going to output. If only 3 out of the 8 are on, it's still going to output. It doesn't really matter. But yeah, so that's basically how the 8 input OR gate works. As far as constructing it goes, you can actually be a little bit more conservative on space with these when compared with the AND gate, because you don't have to channel inputs together. You can kind of do this thing here where you link 3 up to a single gate. So basically what I'm using is 2 3-input OR gates and a 2-input OR gate on the end, which then feed into a 4th 3-input OR gate, which then goes to your output. So in order to make this work with redstone, just because torches are the way you kind of can control this, or at least that's the way I want to use to control the gate logic. When you just have this block with the torch on it, it's technically a NOR gate, so a not OR gate. So in order to get it to output as if it was an OR gate, you just have to throw down a NOT gate, which is easy to do. You just take a block and a redstone torch like that, and it inverts the signal. So as you can see, with nothing turned on, this gate is actually outputting a signal, but we don't want it to be. So by putting it into a torch, this would normally be on, but since it's receiving a signal, it is off. So yeah, that's kind of how that works. Not too difficult. I mean, basically, as far as construction goes, if you have a number of inputs that's divisible by 3, basically if you divide your inputs, so like, let's say we wanted to build a 9-input gate instead of an 8-input gate. If we divide that number by 3, that will tell us how many gates we need on the first rung. So 9 divided by 3 is 3. So technically, we could add a third line into this gate over here. We would want to move it over, so like if we were to build the 9th input right here, this I'll just do it for you because it's pretty easy to set up, honestly. Yeah, that's what we want. So we'll have that one going in there. Boom, boom. And then basically you just connect her up like this. So now we have 9 inputs. Well, we will once we put down the lever. And it still works, so like if we test the new input, it still outputs like it's supposed to. Not a big deal. But that, at least with Redstone, that's kind of how it works. I mean, your default capacity to an OR gate, or a NOR gate, I guess I should specify because that's what it is going to be 3. Whereas with an AND gate, the default that it can accept is only 2. Because if we were to try to do the same thing, like if we added in another line like this, it no longer is an AND gate. Because that turns it off, and really we don't want that turned off unless, well, it will not work. Like that doesn't function as an AND gate. So yeah, that just a little tidbit for you. You can have 3 inputs going into the same gate. If we really wanted to save space, or like you were low on torches, we technically don't even need, or well, actually we do just have it going into 1. So for every 3 inputs, it takes 1 OR gate to control the output. Or each OR gate can handle 3 inputs per 1 output. So like if you wanted to do 12 inputs, for example, you would start with 4 OR gates, and then you would need 2 more, because the second strung, you would have one that would handle 3 like we've got now, but you would need a second one to handle the other remaining input. So that's kind of how it works. I hope that was helpful in explaining and kind of showing you how you can set up multi-input OR gates. It's pretty straightforward, not too difficult. It really is just a matter of having the right amount of space. So like as you can see, these are fairly large footprint gates once you get up there on the inputs, just because you have to have room to run the redstone 1 block apart from each other, otherwise it connects and it will break your logic circuit. But if you were looking to learn more about multi-input OR gates, hopefully this video took care of that for you. If you thought it did and enjoyed the content in general, be sure to like, comment, subscribe as always. And until next time, this has been Lone Debater 7, and we will see ya.